Hello guys, this is Her Majesty Easy World Science channel. Let us look at one of the physics practicals in mechanics and in relative density in particular. You will be provided with materials and you will be given instructions to follow. So the materials provided includes beaker with water inside, then another beaker with kerosene inside, and the kerosene might be labeled any alphabet. In this case, let us take it as L, liquid L, whereas this water is this liquid is water. All right, you are also provided with spring balance and a mass of 50 grams and the other 50 grams masses up to 4, and of course you have your retort stand. So you just connect your spring to the retort stand and you hang the weights. Now the instruction says study the diagram above, that is the diagram we are studying, and use them as a guide as guides in carrying out the following instructions. Using the spring balance provided, determine the weight of the object of mass m equals to 50 grams in A. Record this weight as W1. Determine the weight of the object when it is completely immersed in water contained in the beaker as shown in the diagram. Record the weights as W2. Determine the weight of the object when it is completely immersed in a liquid labeled L. Record the weight as W3. Then evaluate U equals to W1 minus W2 and V equals to W1 minus W3. Repeat the procedure with object of mass M equals to 100 grams, 150 grams, 200 grams, and 250 grams. In each case, evaluate U and V. Tabulate your readings. Plot a graph with V on the vertical axis and U on the horizontal axis. Determine the slope S of the graph and state 2 precautions taken to ensure accurate results. Now, what is good about practical physics is that you are given instruction and then you have to follow the instructions hook, line, and sinker. You don't need to deviate to do what you think, because what you think may not give you the desired result. You have to follow the instruction. All right, like the first instruction here is to weigh the mass 50 grams in A. Wearing it in A means you just hang it. It is not touching anything. So from the spring balance, you can discover the weight. That the weight, when you weigh mass of 50 grams, is 0.50 grams. 0.50 grams. That is the weight. So the weight in A will be labeled as W1. So it is A because it is not touching anything. Now, we weigh it when it is completely immersed in water. That means we have to immerse it in water and we take the weight. Now, the theoretical base is this. There is upward force that is pushing the mass when it is immersed in any liquid. It is that force that we call upthrust. So the upthrust is going to ensure that the weight is reduced because it's going to push the liquid there up. But when it was weight in A, nothing was giving it upward push. So gravity was having its full force on it. So the weight will be a little higher. That is the theoretical base. Now that it is in water, upthrust of water is going to reduce the weight. So that's why we are seeing the weight in water now. It's let's take it as 0.40. That is the weight in water. That is 0.40, and we take it as W2. Then we now also immerse it completely in the liquid called air. The liquid is not water, it must be a different liquid so that they don't exhibit the same level of upthrust, so that you can now use it to compare. So this liquid L sometimes can be kerosene. So of course, naturally, kerosene should be lighter than water. So now, when completely immersed in kerosene or in a liquid labeled L, then the weight is, since it is in between 0.4, in between 0.5 and 0.4, let's take it as 0.45. That is what the reading is here, 0.45. So that is the experiment. Now the very first thing for us to do is to form your table. You don't need to panic about your table. You just follow the instruction to generate your table. From the instruction, we have mass. Then we have weight, W1. We have weight, W2. We have weight, W3. And then we have U, which is gotten by measuring or subtracting W2 from W1. And we have V, which is gotten by saying W1 minus W3. So we might now decide to put serial number in the table. So we have serial number, we have the column for serial number, then we have column for mass, then we remember to put units, then we have column for W1. W1 is weight when you weigh it in A. When you weigh it in A, is W1. Let us also have it in Newton as the unit. Then weight when completely immersed in water will become W2, also in Newton. And weight when completely immersed in liquid L becomes W3, also in Newton. Then the next thing about the table is to evaluate U, which is equals W1 minus W2. And finally, to evaluate V, which is W1 minus W3, all in Newton. All in Newton. So please, that is it about table. Every single column, apart from the serial number, must have the associated Newton. Alright, so it is important for us to be careful with our table, because if we produce wrong table, it will jeopardize the aim of the experiment. Alright, now about serial number, what will give us the information as to where to stop the serial number is the number of masses we are told to provide, 50, and 50 others into 4. So we're going to have number 1, number 2, number 3, number 4, and number 5. So what it means is that we have 5 times we are doing the experiment. We have 5 times we are doing the experiment. And out of the 5 times, we are going to use the first mass to be 50. We record it as 50.0. Why are we recording it as 50.0? Because the masses were provided in the instruction. So we call it as we take it as raw value. So the raw value can be recorded to 1 decimal place. So after 50 gram weight, we are going to perform the exercise on 100 gram, 100.0, then 150.0, then 200.0, then 250.0. That is how we record our raw value. Remember that each column should be recorded in a particular decimal point. We have chosen to record this raw value in 1 decimal point, so that's why we are having 0.0.0.0. So we can't say 50 alone, we say 50.0. We can't say 100 alone, we say 100.0. Just that way. Now, when we did experiments for mass of 50, our weight in A was 0.50, we record. Our weight when immersed in water was 0.40. So that's what we had. And our weight when immersed in liquid L, it was 0.45. So that is the record for the first experiment. So this one is a mere subtraction that we can easily finish up when we are done with the experiments. So let us have the experiment on a mass of 100 grams. The experiment on mass of 100 grams. Alright, having done the experiment with mass of 50 grams, we need to now follow the instruction again and do it with mass of 100 grams. 100 grams means we are going to add another mass of 50 grams. Just add it, the hanger. Yes, I've done the addition. So it's now mass of 100 grams, and then we have to measure the weight in A. It's not in A, it's not immersed in any liquid. So the mass of 100 grams has a weight of 1.0. 1.0. Alright, so that is our W1. We record it as our W1. Then we immerse in water. Water will give it up thrust, up. Give it an upward force called up thrust. So the weight tends to be smaller. Okay, from my reading here is 0.85. 0.85. All right, we record that as W2, 0.85 Newton. Then we completely immerse it in another liquid labeled L. The liquid, we give it an up thrust again. But from my reading, it seems the up thrust of the liquid is less than that of water. So it didn't give it much push. So upwards. That's why the weight, my reading here, is 0.90. 0.90. 0.90. That is the weight when immersed in a second liquid. So we now record it as W3. So with this, we have our table this way. We have our table completed. So as you can see, the table is on the screen. That's the nature of the table you are going to have. And one thing about the table is that each column must be recorded in a particular decimal place. So the second column, that is W1, 2 decimal places, all the weights in 2 decimal places, the U in 2 decimal place, the V in 2 decimal place. So you don't have to write 0.05 then and now write 0.1 only, because it's no longer to the correct decimal place. That's about that. Then we talk about graph plotting, because after that they say we should tabulate our readings, which of course we have tabulated as you can see on the screen. Then the next thing is to plot graph. To plot graph, the question says plot a graph of V on the vertical axis. Very important. So we are going to have V on the vertical axis, all right, against U on the horizontal axis. So the very first thing that calls to mind when you talk about a graph is choosing of scale. So one thing about choosing of scale is that we choose scale to accommodate both the minimum and maximum values in the column you are plotting. Like we are plotting V on the vertical axis, the minimum value is 0.05 and the maximum value is 0.25. So our scale on V axis must accommodate 0.05 and 0.25, and our scale on the U axis, because there is no much variation, should as well accommodate 0.10 and 0.30. So that is it. We choose scale to accommodate the minimum and maximum value of what we are plotting. Secondly, we must have to choose a scale that we use 3/4, that is 3/4 of the entire graph sheet. If you make a small graph, you may not have a space to draw your right angle triangle if you are looking for slope. Right? So the scale, the suitable scale for the readings, as we can see on the screen, is on the V axis. We have 2 cm to represent 0.05 Newton. We say unit in mathematics, but physics is applied mathematics. So now we are specific about the unit. The unit is Newton. And also 2 cm to represent 0.05 Newton on the U axis. So when you plot the graph, gently plot the graph, you have a straight line graph, but it will not pass through the origin. It has intercepts on both vertical and horizontal axis. What is this intercept? Intercept is the point where the line of best fit cuts the both axes. The point where the line of best fit.
Wait a minute. If you enjoy content like this and would like to see more from Her Majesty Easy World Science channel, don't forget to hit the subscribe button down below and share to your friends and family. Much love, remain majestic. Hi, I wanted to tell you that you can contact Her Majesty Easy World for your laboratory equipment and reagents. They are affordable and provide accurate results too. Her Majesty Easy World only sells what he knows, and his patterns of delivery are sure and certain. Place your orders today. Thanks for your patronage.
So the intercept on the horizontal axis is where this line of best fit cuts the horizontal axis. That is exactly at 0.05. It's not in our question today, but they may still ask it. It's at 0.05. Then the intercept on the vertical axis is where the line of best fit touches the vertical axis. Is exactly at minus 0.05. Why is it minus? This is the origin, 0. On the vertical axis, where you are moving from origin down, is negative. So the intercept on the vertical axis is minus 0.05. And on the horizontal axis is minus plus 0.05. That is about intercept. Now slope. If we have a line of best fit that is straight, we draw a reasonable sized right angle there, triangle. From there we can calculate our slope. The reasonable, my own triangle this way. Then you trace the triangles from the vertices. Trace from this vertex, you trace it down. From this vertex, you trace it down. From this vertex, you trace it up. From this vertex, you trace it up. Remember that the natural formula of slope in mathematics is dy over the x. But in physics, we are going to be specific. What is on the vertical axis is v, so it's going to be dv over du. So it means v2 minus v1 over u2 minus u1. So let's look at what is v2. If you move from 0 and you are moving up, you first meet this your tracing here. So we call it v1. And the value is 0.10. Then our v2, when you move again, where your dot touches the vertical axis is 0.25. That becomes our v2. So our v2 is now 0.25 minus our v1, 0.10. Then let's talk about u. The dot is here for u2. That's 0.30 minus our u1, 0.15. So that's how we can calculate the slope. Now, when we subtract this, it will give us 0.15 over 0.15. That will give us 1. Alright, having done this, let us look at unit of slope. Unit of slope. The unit of slope can be gotten by what you plotted. You plotted Newton on the vertical axis, and you also plotted the Newton, because V is weight measured in Newton and U is also weight measured in Newton. So when Newton cancels Newton, it becomes nothing. So it means it cancels out. So the slope has no unit. It's a ratio of same quantity, so it has no unit. But assuming we plotted mass against weight, it is going to be kilogram, or rather gram, as we can see in this particular experiment, gram over Newton. And when we take Newton as denominator and we take it up as numerator, it becomes per Newton. That is gram per Newton. It will now accept a minus sign. So that's how you can calculate your units after calculating your slope. Having done the calculations, slope, and the intercepts I taught you how to get, even though it's not in our question today, the next thing you should do is to take care to write the precautions taken to ensure accurate results. There is one precaution that we know very well. We should avoid error due to parallax. But when we state we should avoid error due to parallax, it means you are telling the examiner what to do. So precautions are stated as reported speech. You are reporting what you did, and when you now mention error due to parallax, you must state the object you were using, the apparatus you were using, that you tried to avoid the error due to parallax. Meanwhile, error due to parallax is the error you see, the error will come about when you are not placing your eyes very well the way it should be, when you are viewing something, when you are viewing a particular thing, or when you are taking a particular reading. So if we decide to go by that, say, I avoided the error due to parallax when reading my spring balance. So you must mention spring balance so that they will now understand that you were not just mentioning the error due to parallax, error due to parallax. You avoided error due to parallax while reading the spring balance. Because if I decide to place my eyes this way, I will experience error due to parallax. If I decide to bend down, I may as well experience error due to parallax, so I have to place my eyes straight while reading it so that I will avoid error due to parallax. Then another precaution in this experiment is to ensure that the mass is not touching the body of the beaker. It's completely immersed in liquid or water, but it's not touching the body of the beaker, because if it touches the body of the beaker, it is no longer the up thrust that is acting on it. The contact is already having effect, and that will jeopardize our reading. So I made sure that my mass was not touching the body of the beaker. So that's how to report precautions. Thank you. Thank you.